Okay, so welcome to the deep dive. And, we like to just jump right in, and today is no different.
Absolutely.
We have some seriously groundbreaking news to kind of unpack here. Meta has just unveiled its Llama 4 family of large language models, and this isn't just some sort of, incremental update or a minor tweak. This feels like a real shift,
Yeah,
especially in how these AI models can now perceive and understand the world around them.
absolutely. And we're taking a look at Meta's official announcement, their blog post about what they're calling the Llama 4 herd.
Right.
And for you, the listener, our goal is really to dissect this. We want to extract the core advancements,
Yeah.
figure out what makes these models so innovative, simplify some of the more technical details so we can all grasp
Right.
the genuine significance of this release.
Right. And the listener, you're looking to get informed quickly but thoroughly.
Yeah.
And I think there's going to be some real aha moments as we explore what Meta has brought to the table here.
Yeah.
Okay, so let's get right into it. They haven't just announced one new model, but an entire Llama 4 family. So
Right.
who are the key players that we should be aware of?
So there are three main models that are really worth focusing on. The first up is Llama 4 Scout.
Okay.
And what's particularly remarkable about Scout is its efficiency. It can actually run on a single NVIDIA H100 GPU, which is quite an achievement for a model with this level of capability.
Wow.
So you can actually have, this powerful LLM, without needing a massive server farm.
Right.
And it also boasts an incredibly long context window of 10 million tokens.
10 million tokens, that just sounds like a massive amount of information that it can kind of handle at once.
It is. It means Scout can process and understand a huge volume of information in a single gust. Imagine being able to feed it the entire history of a large project,
Right.
years of customer interactions, or even a substantial code base, and it can reason across all of it.
Wow.
Architecturally, Scout has 17 billion active parameters and utilizes a mixture of experts approach with 16 experts.
Okay, so 17 billion active parameters. That's pretty substantial. How does Scout compare to, some of the other leading models out there?
So according to Meta's data, Llama 4 Scout performs better than models like Google's Gemma 3,
Okay.
Gemini 2.0 Flashlight, and Mistral 3.1 across various standard AI benchmarks. It's a very capable and efficient model in its category.
That's impressive in terms of packing a punch without needing a huge infrastructure behind it. So what's the next member of this Llama 4 family that we should know about?
That would be Llama 4 Maverick.
Okay.
And this one is positioned as really excelling in terms of how much performance you get for the cost. And it really shines when it comes to understanding and processing different types of information,
Okay.
like text and images, what we call multimodal capabilities.
Right.
It also has 17 billion active parameters,
Okay.
but a much larger number of experts, 128 in this case,
Wow. Okay.
and a total of 400 billion parameters.
So a lot more specialized subnetworks at work in Maverick. So what kind of performance are we seeing with this model?
So Meta indicates that Llama 4 Maverick outperforms both GPT-4o and Gemini 2.0,
Yeah.
Flash across a wide range of benchmarks.
Wow.
What's particularly interesting is that it achieves comparable results to the very recent DeepSeek V3
Okay.
on tasks like reasoning and coding, but with significantly fewer active parameters,
Right.
less than half.
Wow. Okay.
There's also an experimental chat version of Maverick that's
Interesting.
performing very competitively on the El Marino leaderboard, which is a public benchmark for conversational AI.
Okay, so that sounds like a really powerful and versatile model. Now, you mentioned a third model that's still in development. So tell us about Llama 4 Behemoth.
Yes, so Llama 4 Behemoth is the teacher model in this group.
Right.
It's not yet available publicly, but it's absolutely vital because both Scout and Maverick were actually derived from it through a process called distillation, where a smaller model learns from a larger, more capable one.
Interesting. Okay.
Behemoth operates on a completely different scale. It has a massive 288 billion active parameters, nearly 2 trillion total parameters, and 16 experts.
2 trillion parameters.
It's hard to even imagine.
That's hard to even imagine. So what kind of performance does that translate to?
Well, Meta reports that Llama 4 Behemoth outperforms some of the most advanced models currently available, including OpenAI's GPT 4.5,
Okay.
Anthropic's Claude Sonnet 3.7, and Google's Gemini 2.0 Pro on several benchmarks that focus on science, technology, engineering, and mathematics.
Wow.
So it's positioned as an incredibly powerful and intelligent foundation model.
Okay, so we've got Scout focusing on efficiency and incredibly long context.
Yes.
Maverick balancing high performance with multimodality.
Right.
And Behemoth as this massive, highly capable teacher model that's kind of pushing the boundaries. Now, a major highlight in the announcement was native multimodality.
Right.
So what does that practically mean for these models?
Yeah, this is a really significant step forward. So natively multimodal means that Llama 4 is designed from the ground up to understand and process both text and visual information together, right from the very beginning of its training.
So it's not like tacking on the ability to see as an additional feature later on.
Exactly. It's deeply integrated.
Right.
And they achieve this using a technique called early fusion, where the text and visual data are combined early in the model's architecture.
Okay.
And they've also enhanced their vision processing component, which is based on their Metakeelup model, but has been specifically trained in conjunction with a core Llama language model that remained unchanged during this vision training.
Okay.
This allows the vision encoder to better understand and align visual information with the kind of textual understanding the language model possesses.
So it's kind of like our brains naturally process, what we see and what we read together rather than treating them as completely separate inputs.
Exactly.
Okay, that makes a lot of sense for a more unified understanding of different kinds of data. Now, another term that kept coming up was mixture of experts, or MOE architecture. So can you explain how that works and why it's such a key part of Llama 4's design?
Certainly. So in a traditional large language model, all the internal connections or parameters are active for every single piece of text it processes.
Okay.
In an OE architecture, the model has these different experts or subnetworks.
Right.
And for any given input, only a small fraction of these experts are actually engaged.
Oh, interesting.
The model learns which expert or combination of experts is best suited to handle different types of information or tasks.
So it's kind of like having a team of specialists inside the model, and it calls on the right specialist for the job.
That's a very effective way to think about it.
Okay.
As we saw with Llama 4 Maverick, even though it has a total of 400 billion parameters,
Right.
only 17 billion are active for any single input, utilizing 128 of these routed experts along with one shared expert.
Okay.
This approach makes both the training and, crucially, the use of the model what we call inference much more efficient. Meta even highlights that Llama 4 Maverick can run on a single NVIDIA H100 DGX server, which makes deploying such a powerful model much more accessible.
Right.
It's like having a supercomputer that doesn't require an entire warehouse to operate.
Right. That's a huge practical advantage in terms of accessibility. Okay, so let's go back to that incredibly long context window of 10 million tokens in Llama 4 Scout.
Yeah.
You mentioned some of the things it enables, but can you delve a bit deeper into the underlying technology that makes this massive context window possible?
Absolutely. Achieving such a long context window presented some significant technical hurdles.
Yeah.
And they've come up with some innovative solutions. So they initially trained Llama 4 Scout with a context length of 256,000 tokens.
Okay.
Which is already quite substantial and provides a strong base for handling longer sequences.
Right.
But the real breakthrough is the IRO-P architecture.
IRO-PE, that sounds quite technical. So what's the core idea behind it?
So it stands for interleaved attention layers without positional embeddings, with the I also hinting at the longer-term aspiration of potentially supporting infinite context in the future.
Interesting.
Many language models use positional embeddings to tell the model the order of words in a sequence.
Okay.
IRO-P takes a different approach using interleaved attention layers instead of explicit positional embeddings.
Okay.
They also use a technique called inference time temperature scaling of the attention mechanism, which further helps the model generalize effectively to these extremely long sequences.
Okay.
This combination allows Llama 4 Scout to process and reason over those massive amounts of data without the performance degradation that often occurs with very long contexts in other models.
That's a clever way to overcome the traditional limitations of long context. Now, the blog post also mentioned some interesting innovations during the initial training phase.
Right.
So tell us about MetaP.
So MetaP is a new technique they developed to reliably set the critical initial settings of the model, things like the learning rates for different parts of the model and how the model's internal weights are initially configured. Yeah. What they found is that these carefully chosen initial settings seem to work well across a range of different training scenarios, regardless of factors like the size of the training batches, the overall size of the model, or the total amount of training data used.
Okay.
This kind of robust hyperparameter setting can really streamline the training process
Makes sense.
and lead to more consistent and better performing models.
Yeah.
It takes some of the guesswork out of training these massive AI systems.
Yeah, for sure. That sounds like a valuable step towards more efficient and predictable AI development. Uh, what about the multilingual capabilities they highlighted?
Yeah, this is another really important aspect for building truly global AI.
Right.
Llama 4 was initially trained on a massive data set that includes text from 200 different languages.
Wow.
Impressively, over 100 of those languages had more than 1 billion tokens of data each in the training set.
Okay.
That's 10 times more multilingual data compared to the previous Llama 3 model.
Wow.
This extensive multilingual training should significantly enhance the model's ability to understand and generate text
Right.
accurately and fluently in a wide variety of languages.
Right. That's crucial for creating AI that can communicate effectively with people around the world. And what about the efficiency of the training process itself?
Yeah.
I mean, training these massive models must be incredibly resource intensive.
It certainly is, and Meta focused heavily on making it as efficient as possible.
Yeah.
They utilized FP8 precision, which is a lower precision way of representing numbers in the computer's calculations
Okay.
without sacrificing the quality of the resulting models. This allowed for faster computations and reduces the amount of memory needed during training.
Okay.
They also achieved very high utilization of their powerful GPUs. For Llama 4 Behemoth, they reported using 32,000 GPUs
Wow.
at a utilization rate of 390 TFLOPs per GPU.
That's a lot of processing power.
Yeah. Furthermore, the total amount of data they trained on was enormous, exceeding 30 trillion tokens, which is more than double the amount used for Llama 3. They also mentioned a process they called mid-training, where they continued training with specialized data sets to further improve the model's core abilities
Okay.
and extend their context window capabilities.
Mm.
It's like athletes doing specialized training
Right.
after their main conditioning to hone specific skills.
Right. So continuous refinement, even after that initial massive training phase. Now, the post-training strategies also seemed quite detailed,
Right.
particularly for Llama 4 Maverick.
Yeah.
So what were some of the key approaches they took after that initial training?
Yeah, for Llama 4 Maverick, a key challenge was ensuring it performed well across different types of data, text, and images,
Right.
as well as being strong at both reasoning and having natural-sounding conversations.
Okay.
They employed a multi-stage post-training process. They started with a lightweight form of supervised learning called supervised fine-tuning, or SFT,
Right.
then moved to online reinforcement learning, or RL,
Okay.
and finally used a lightweight version of direct preference optimization, or DPO.
Okay, interesting. So why this kind of multi-step approach?
Right.
What does each stage contribute?
So they found that relying too heavily on traditional SFT and DPO
Okay.
could sometimes make the model too rigid,
Okay.
limiting its ability to explore and learn during the reinforcement learning phase,
Interesting.
which could negatively impact its performance in areas like reasoning and coding.
Okay.
To counter this, they actually removed a significant portion, over 50% of their easy SFT data,
Okay.
using the Llama models themselves to judge the difficulty of the data.
Interesting.
The subsequent lightweight SFT was then performed on the remaining more challenging data set.
Okay.
In the online RL stage, they focused on using more difficult prompts
Okay.
and implemented a continuous online learning strategy where the model was constantly being trained and then used to filter and keep only the medium to hard difficulty prompts for further training.
Okay.
This proved to be very effective for both computational efficiency and improving accuracy on complex tasks. Finally, the lightweight DPO was used to fine-tune the model's response quality and ensure a good balance between its intelligence
Okay.
and its ability to engage in natural conversation.
Mm-hmm.
So it's a very carefully calibrated process to get the model to perform optimally across a range of abilities.
Okay. That sounds like a very sophisticated and iterative process to really hone the model's capabilities.
Yeah.
What about the post-training for the massive Llama 4 Behemoth?
Right.
Were there any significant differences in their approach given its scale?
Yes, given its much larger size, the post-training for Behemoth required even more significant adjustments.
Okay.
They actually pruned an even larger percentage of the initial SFT data, 95%,
Wow.
to really focus on the highest quality examples.
Okay.
They also discovered that large-scale reinforcement learning, following a lightweight SFT, led to even greater improvements in its reasoning and coding abilities.
Okay.
Their RL strategy involved actively selecting harder prompts based on the model's performance and creating training batches that included a diverse mix of prompts designed to test different capabilities.
Oh, okay.
They also emphasized the importance of using a wide variety of system instructions
Right.
to ensure the model maintained its ability to follow directions effectively across different kinds of tasks.
Okay.
Scaling RL to a model with nearly 2 trillion parameters
Mm.
also required a complete redesign of their RL infrastructure,
Right.
which resulted in significant gains in training efficiency. It's a testament to the engineering challenges of working at this scale.
Yeah. That's incredible. Now, a crucial aspect of any powerful AI model is its availability and the ecosystem around it.
Right.
So what did Meta share about when and how people can access these new Llama 4 models?
So the good news is that Llama 4 Scout and Llama 4 Maverick are available for download right now on llama.com.
Wow.
And Hugging Face.
So immediately accessible.
This makes them immediately accessible to developers and researchers. Furthermore, they are also integrated into Meta AI within popular platforms like WhatsApp Messenger, Instagram Direct,
Okay.
and on the meta.ai website, so people can start interacting with their capabilities directly in these everyday applications.
All right.
Meta also announced an upcoming LlamaCon event on April 29th,
Okay.
which will likely provide even more in-depth information and opportunities for the community.
Okay, so these advancements aren't just theoretical. They're being actively rolled out and made available to both developers and everyday users. So what kind of overall impact do you anticipate these Llama 4 models will have, and what are some of the broader implications you see for the future?
Yeah, the potential impact is substantial. The enhanced performance, the native ability to understand both text and images,
Right.
and especially the incredibly long context window of Llama 4 Scout
Right.
could pave the way for entirely new kinds of personalized experiences and powerful tools.
Yeah.
Developers will have access to more capable and efficient models to build innovative applications
Right.
across a wide range of fields. It also really underscores the importance of the entire AI technology stack, from the underlying models themselves
Right.
to the infrastructure that supports their training and deployment,
Right.
as well as the collaborations and partnerships that enable their widespread use.
Yeah.
It's not just about the models. It's about the whole ecosystem that brings them to life.
Right. So to kind of bring it all together for you, our listener, it's clear that the Llama 4 models, particularly Scout and Maverick, represent a significant step forward in the world of AI.
Absolutely.
We're talking about a compelling combination of power and efficiency, true native understanding of multiple types of data, a groundbreaking ability to process very long sequences of information, and a clear commitment to making these advancements accessible. It certainly feels like Meta is pushing the boundaries of what's possible with large language models.
Exactly. And hopefully this deep dive has provided you with a clear and engaging understanding of these important developments,
Yeah.
demystifying some of the technical aspects to highlight what truly matters and why it's significant.
And on that note, here's a final thought for you to consider.
Yeah.
Especially given that remarkable long context capability of Llama 4 Scout.
Right.
Think about how a 10 million token context window could fundamentally reshape how AI interacts with and comprehends vast amounts of information from your own personal digital archives.
Wow.
To complex scientific research, what entirely new possibilities does this extended memory unlock for the future of AI applications, and what might that mean for you in your own areas of interest and work?
Right.
We encourage you to explore these advancements further with the information we've discussed,
Yeah.
and to really consider the potential impact in your own world. Thanks for joining us for this deep dive.
Absolutely.